All right, for this lesson, you're going to need to have either your Desmos Scientific Calculator app pulled up on your phone. If you have a calculator, like a graphing calculator, you can use that, or pull up Desmos Desmos Scientific Calculator online because we will need to use that today. So the first question we're going to look at here, this is based off of our writing exponential functions lesson. So inaugural attendance of a music festival is 150,000. The attendance increases 8% each year, and we need to figure out how many people will attend in the 5th year. Well, this is growing by a percent, so I'm going to use my 1 plus r function. So in this case, I know that A is 150,000, R is 8%, which we remember we have to convert into a decimal. Our t value, since it says each year, that would mean 1. And in this case, x is how many years have gone by. So now I'm not just substituting in things that I know for the equation. I'm actually going to get an answer in the end. So in this case, I have 150,000 times 1 plus 0.08 raised to the power of 5 divided by 1, which is just going to be 5. And I'm going to put that in my calculator the exact same way I see it here. You could also simplify this and do 1.08, and that would be fine too. Now to get to the exponent, I use this AB button right here. Oops, wrong one. And I'm going to put in 5. So this will be my attendance. Now, since this is people, 220, 399. And they said to round our answer to the nearest 1,000. So that would be 220,000. And since this is a word problem, my answer is also going to have units. So that would be 220,000 people. Next, we're going to look at this question about medication. So taking 40 milligrams of medicine, it's decreasing 15% each hour. So that tells me I'm doing decay by a percent. So A is the 40 milligrams we start with. R is the 15%, which I need to convert into a decimal. X and T, well, T is the time for one decay, so that would be 1 hour. Total is 4. So I'm going to have 40 times 1 minus 0.15 to the power of 4. So 40 times 1 minus 0.15 raised to the power of 4. And it doesn't tell us a decimal place. So usually I do 2 just to be on the safe side. These are in milligrams. So that would be our answer for that one. All right, now we have a bacteria that is quadrupling. So that tells me I'm going to have this equation here. So I have A, B, X, T. So every 3 minutes tells me my T value. Beginning with 5 bacterium, that's A. Quadruples tells me that B needs to be 4. Now, I don't know the time because they're asking me to find how many minutes it's going to take. So I know that my Y value, I'm looking for it to be 100 or more. So actually, the better way to say this is just to use an inequality. I want to know when Y is going to be bigger than 100. So there's a couple different ways you could go about this question. You could make a table, and we'll do it with a table first. So at no minutes, we're going to have 5 bacterium. Now it's every 3 minutes, it quadruples. So in my X column, I need to go up by 3. And I'm going to add 3 on this side. And then on the other side, I'm going to multiply by 4 because that's that quadrupling that we're seeing. So at 3 minutes, we'll see 20. At 6 minutes, if I multiply this by 4, we'll see 80. And then 9 minutes, we would see, 320. So our table isn't super helpful because it's going to happen somewhere in here between 6 minutes and 9 minutes. So what I'm going to do is I'm going to actually take my calculator and I'm going to use my calculator with other X values between 6 and 9. And I'm going to look at 5 times 4 to the power of X over 3. So I know what it is for 6 minutes. So 5 times 4. So in my exponent, I'm going to do 7 divided by 3. Well, when X is 7, because I made my numerator 7, so our Y value was 126.9, so 127, since these are bacteria. It has to be a whole number. So this tells me that it's going to take 7 minutes to be more than 100 bacterium. It cannot be 6 minutes because 6 minutes was 80. Now, if you only used your calculator and you did not make a table first, you would do the exact same thing I just did and start substituting in numbers. So if I did 6 divided by 3, you'll see that gives me 80. So I would just keep substituting in values here in the numerator for X. All right, moving on to the next one. We have 2 more. The website has 500,000 members in 2010, and the number of members increases by 15% each year. So this, since that's the beginning, this is going to be represented by X equals 0. So every X value we substitute in is how many years after 2010 has gone by. So since this is increasing by 1%, I'm going to use my increase by 1% formula. So I have Y equals 500,000 times 1 plus, turning this into a decimal would be 0.15. It says each year, so t is 1. So my exponent is just x. Now they want us to figure out what's going on in 2016. Well, this would be x being equal to 6 because it's 6 years past 2010. So I'm going to take this formula and substitute 6 in for the exponent. 1 plus 0.15 to the power of 6. And again, it says round to the nearest 1,000. So originally, I have 1,156,530. Here's the 1,000, so that's actually going to round up. So it would be 1,157,000 members if we're rounding to the nearest 1,000. The last thing we're going to look at is actually a new formula. This is compound interest, and this only applies if you see the word compounded in your word problem. If you do not see the word compounded, you do not use this formula. So principal amount is your initial deposit into this account. This is a simple example of how money grows in a bank account. And so we're going to use this formula for any question that says the word compounded. So we're depositing $100 into a savings account. So this is going to be my initial deposit. It's earning 6%. That's my rate. And it's compounded monthly. So we have to do two things. We have to write the function and then see how much money we would have after 10 years. So just to write this back over here. All right, so P is our initial amount. So P is 100. R is 6%, but remember I have to write this as a decimal. So it'd be 0.06. N is how many times it gets compounded each year. So since it says monthly, that means this is going to happen 12 times in a year. So we're going to see this as y equals 100 times 1 plus 0.06 divided by 12 to the power of 12t. And then what I'm going to do here is substitute in t equals 10. And you can put your formula in just like this into your calculator. So I have 100 times 1 plus, I'm going to hit the fraction button over here, 0.06. I'm going to arrow down to the bottom, divided by 12. We have to close the parentheses. And then in the exponent, we're going to do 12 times 10. Now, in the Desmos Scientific Calculator, if you are multiplying in your exponent, you do have to put parentheses, or you could just do 12 times 10 being 120 and put that in that way. But either way, you're going to have $181.94 after 10 years.